Hi guys, welcome to the second filming of special derivatives that we're going to look at. Last time we looked at the product rules. This time we're going to look at the quotient rule, and it's going to look at when we have a function divided by a function. Okay, and like the product rule, we could go back and look at the limit definition, but we're not going to on this one. I'm just going to tell you what this one is. It's very similar to the product rule, but there is a very important change. So just like the product rule is going to be f prime of x times g of x, and then we're going to subtract when we divide. We're going to subtract, and so then we're going to have f of x times g prime of x. Now, so far so good. Everything here is mostly the same, but we are going to have a denominator. We're going to have g of x squared in our denominator. Okay, so we're going to look at quite a few examples here. So I'm going to take this with us, make sure that we have all of these so that we can copy them and use them in our forms. And whoa, that's way too big. So let me see if I can't put these all together here, and we're going to make this a little bit smaller to keep for some notes here. All right, so we'll keep that right there. Okay, so this is an example of something that we've already done, 8 over x squared, and hopefully you recognize that what we should do here is we're going to write this as f of x equals 8 times x to the negative second, and so then the derivative is negative 16. There we go. Well, let me make that better. Negative 16 x to the negative third. Well, let's see how the quotient rule applies here. All right, so we're going to take the derivative of 8. And so hopefully you recognize the derivative of 8 is 0. We're going to take that times x squared. Minus f of x is 8, and then it's the numerator, right? And then the derivative of the denominator is 2x. And so then we're going to put that all over x squared. Well, when we simplify this, this goes away. So we get negative 16x over x to the fourth. And that should make sense that that is negative 16x to the negative third. So just for your benefit and to show you that the quotient rule really does work, we've taken this derivative now 2 ways. Once in this simple manner, I think you should do it. But then you could also use the quotient rule, and you get the same thing. And when it simplifies, this is what you get. All right, let's look at a little bit a more challenging one. And let's bring this mess here. That's not what I wanted to do. Let's bring this mess here. Let me try this one more time. I apologize. All I'm doing is wasting your time here. Here we go. We'll bring this over. There we go. That's a lot better. All right. So let's look at this. We're going to start out by taking the derivative of the numerator. So f prime here is 6x plus 2. Okay, times g of x. So that's 2x plus 5, okay, minus, all right, so I'm going to write this out. This is f prime g minus f of x is 3x squared plus 2x minus 1. Let me write that a little nicer for us. 2x minus 1. So that's f. And then g prime is 2. And we're going to put all of that over 2x plus 5 quantity squared. Now, go ahead and raise your hands if you want to FOIL this. Right? We could FOIL that. We can distribute this negative 2 through here. And we could simplify this, but we're just not going to, guys. So what we're going to do is we're going to leave this in red as your answer. Okay. Now, there may be times when we have to solve equations. Okay. And we'll talk about how to deal with that. But for right now, we're just going to leave this as is. We're not going to simplify this at all. All right. Now, why is the quotient rule really important? Well, I think it's important because it's going to help us find this derivative. Okay, so from trigonometry, you remember that tangent of x is equal to sine of x over cosine of x. And so now we're going to take the derivative, and remember it's f prime g. So that's cosine of x times cosine of x minus, then it's f g prime. Well, that's sine of x times the derivative of cosine is negative sine of x. Again, if any of this is going too fast for you, please pause it, and we will stay right here until you're done. Okay, so then we put that over g squared, right? If we need to, there, oh my goodness. I should practice this before I do this. So there, we follow that. All right, well, let's simplify this now. Let's simplify. So we have cosine squared of x plus sine squared of x. Notice the two negatives. All over cosine squared of x. And so for you trigonometry majors out there, remember that cosine squared plus sine squared equals 1. So this is 1 over cosine squared of x. And you guys will recall that 1 over cosine squared of x is equal to secant squared of x. So that's something that you can know. We'll probably talk about that in class a little bit. But the derivative of tangent of x equals secant squared of x. All right? So those are 3 examples of the quotient rule. If you want to look at the limit definition of a quotient rule, you can certainly do so.